Hey folks, how's it going? Today we're going to be having a lot of fun continuing our journey with the Z camera, and what we're going to be doing today is learning how to actually create 3D scans directly inside of TouchDesigner. You can see here I've done a great scan of my notoriously messy desk that I'm working at. That's just a way of life. I got no other comment about it. But we can see that not only are we able to generate these meshes dynamically, but we're also able to texture them, and it's a really cool and easy to go through process. So what I'm going to do is delete everything here, and we're going to get started from scratch. So the first thing we're going to do is a quick scan of just my face. That way I can stay in the classic developer tradition of moving as little as possible. And once we take a look at some of the parameters, we'll go into tweaking them, tuning them, and then I'm going to stand up and do a quick scan of my desk. And probably what we'll do in the next video next week is even go mobile with our laptop setup once you get a little bit of a hang of how to do these scans. And we're actually going to go outside and scan some environments, which should be really cool and something that's really easy to do with the thankfully one cable setup of the Z camera. So the first thing we're going to do inside of TouchDesigner is set up our Z SOP here. And the Z SOP is going to be responsible for interacting with the actual Z SDK that does this spatial mapping, as they call it. And if you're curious about this spatial mapping process, the Z documentation, which I have just over here, is really great. And like I was mentioning in our other video, it really feels like this was a device made for professional developers to work with. They have a whole section about how it works, what you can do with it, the different options. So it's actually the Z SDK that deals with all of this information. And inside of TouchDesigner, we're basically activating and deactivating different features and parameters and getting the results from this process back. So the Z SOP is something we're absolutely going to need. The next thing we're going to need is actually a Z top. So I'll go ahead and make my Z top here. But unlike normal, where we might set up our color camera, we actually want to switch this image mode from color over to spatial texture. Now, when you do that, you're immediately going to see a little warning that says the spatial mapping texture is not enabled, but don't worry, we're going to get to enabling that. But you kind of need this Z top here to be able to receive the results from our 3D scan. So that's perfectly normal right now. So let's even do our first kind of example scan here. And what I'm going to do is, with all of the default parameters, hit a scan, show you what it looks like, and then we're going to start tweaking some of these parameters. So I'm going to go ahead and put the Z on my table here, just a little bit farther away from me. And with me here, I also have a guest, which is a light. Because remember, unlike sensors like the Kinect, or I guess really the Kinect is the main one you've probably used, this is an optical sensor. That means it's not using infrared patterns, it's not measuring anything like that, it's not a LiDAR sensor. It has two cameras and a lot of algorithms. So you'll really want to make sure that whatever environments you're doing any of these scannings in, or even just using the Z camera overall, you want to have them be as well lit as possible. So I have this light here so that I can fully blind myself while doing the 3D scan, but that is actually really going to increase the quality of our scan. So let's just go ahead and run this once just so you learn how the process works. So our Z camera is sitting idle with its Z SOP, and this process is specifically not real time. And what I mean by that is that it's not a process where you're going to start scanning and as it's scanning get the results back. It's a two-step process. The first step is we start our scan. In that process, the Z is capturing all of that information, and then we're going to hit stop scan. It's going to go behind the scenes, create that mesh, and give it back to our Z SOP. So if you were hoping for something that you could kind of hit a button and just kind of get meshes spitting out in real time, that's not what this process is, but there's still a lot of creative potential here. Now, this process is really going to be anchored by our sample button here. So by default, if you have your Z plugged in, it's automatically going to populate the device. And I can go ahead and sit still in front of my Z camera, hit sample, and I'm going to see, oops, I hit reset by accident. I'm going to see it's starting to fill in inside of the SOP the different points that it's finding and scanning. So you can see I'm up in the front here, and these are the walls behind me. And once you're done your scan, which I usually say if it's a static scan, give it maybe 5 or 10 seconds. It does go through and fill in a lot of points. Once you're done, you can go ahead and hit sample. It's going to finish the process and report back to us a mesh. Now, there's a couple problems with this mesh that we have just created in that, one, it looks very low resolution, and two, we actually didn't get anything returned to us in terms of textures. Now, this is where all of our other kind of parameters come into play. So a lot of these parameters you're probably going to want to tweak, play with, experiment with, and really understand how they work and how they would impact the results you're going to get. And it might also depend on what kind of system you're using. So I'm using a Razer 14 here, so it's got a pretty beefy CPU, beefy GPU, so I can kind of push the limits of what I want this to do. So for example, one thing I really like doing is switching my limited preview over to a full preview. So if you have the horsepower for it, this is great, because if I hit sample again, what we're going to see is a much more dense preview that really actually helps us see what is going on in a much more kind of intuitive manner here. Now, that is not really going to change the result we get back. It's just going to make it a little bit easier. So if we're walking around and scanning things, we can actually look inside of our ZSOP and see a little bit better what's going on. Now, the next three parameters that we have here are the maximum memory, the resolution, and the range. So our maximum memory is the maximum amount of data that we're allowing the ZSDK to kind of save and use for this mesh. So at 1024, that's 1 gigabyte. And I would say unless you really have less than 8 gigabytes of memory on your PC or on your Mac, you should just crank this up. You know, set it to 4096, set it to 8000. Really let Z take full advantage of your available memory. I think in most computers, especially ones that we're using in this industry, we're probably going to have way more CPU memory than we need. Now, it is important to remember that this is CPU memory, not GPU memory. So what we can do is say, you know what? I'll even set this to something like 8000. So it's hovering around 8 gigabytes on my laptop, which I have 16 gigabytes of RAM. That's perfect. Now, resolution is an interesting one because it actually tells the ZSDK in what kind of increments of measurements to actually take its scanned points in. Now, when we set it to 0.03, that's essentially 3 centimeters. So this is a unit in meters. So if this was set to 1, which you can't really set it to 1 because doing scans in 1 meter increments is not good. But you can see here it goes from a range of about 20 centimeters when it's in the lowest resolution down to about 1 centimeter when it's in its highest resolution. So in this case, because I'm scanning myself, I'm going to turn this down to 0.01, which is going to give us 1 centimeter increments for all of the sampled points, which is going to translate into the highest resolution for us. Now, it definitely should not be a thing where you're imagining that you're going to get the Z camera and this is going to replace professional 3D scanners that are going to be able to pick up, you know, every wrinkle and every unshaven hair on your face potentially. But it really is great for quick scans, environmental scans, and scans that you're going to use more for artistic purposes than for engineering purposes. It can even be a great tool if you're trying to do a preliminary setup of something like Cam Schnapper or some projection mapping setups, and you want to just have a rough sense of the scale and size of the environment. It can be really great for those things, but it definitely does not replace professional 3D scanning solutions. So now that I have that set to 1 centimeter, I also want to tell it the range of what I'm trying to scan. Now, the Z's range is really incredible. We'll probably see next week in our next video as I go outside and scan some trees and shrubs and things like that, that the range of the scan really does go up to that advertised feeling of around 20 meters. So you can actually scan for a long distance. But when we're doing these spatial mappings, we actually want to tell the ZSDK, you know, it's almost like a focal length. The object that I really want the best scanning results for from the spatial mapping is around this number of meters. So in this case also, because I'm pretty close to my Z camera here, and when I stand up and I'm going to be scanning my desk here, I'm also going to be pretty close to it. I'm going to turn this down to 2, which is kind of the minimum that it lets you go down to. Now, if I was outside and maybe scanning a house or scanning a car or something like that, or just an environment, I might want to keep this higher, maybe around 10 meters as my kind of focal length, or maybe even up to something like 18 or 20 meters. Now, in this case, I'm going to bring this back down to 2. So if I run this exercise again, and I pose up for my Z camera, and in this case, we have to actually reset our scan, because if I just turn on the sample, it's just going to keep incrementing on top of that. So I'm first going to pulse my reset. That's going to clear out the last set of results I had. And now I can go ahead and hit scan again. And you're going to see now we're starting to get a much more high fidelity scan in here. And I can hit W while I'm looking at my geometry here. And I can actually see, there's a lot more detail. Now, this is, like I was saying, it's not going to replace professional 3D scanning equipment, but you can even see it's getting some general ridges, valleys and all that kind of stuff in my face, as well as having a little bit of a decent body scan here. Now, we have a mesh, but we don't really have any of that color information yet, which is where it starts to get exciting, especially for artistic purposes. Maybe you want to scan an environment and then be able to fly through it with a 3D camera. So this is where our final few parameters come into play on the Z-SOP. So these buttons down at the bottom, normals and textures and filter. Those are the 3 main ones that you'll probably end up playing with, but you can see they're actually grayed out until you activate the scanning mode. So in this case, what I'm going to do is hit reset, kind of get into position here for my scan. I'm going to hit the sample button to on. And while you're doing this, I should say, the camera is the thing that should move, not the things inside of the environment. Actually, I can even do a quick example. If I start moving like crazy while that scan is happening, it's going to return to me the craziest mesh of, a broken, 7-headed person, almost terrifying what, an Elbers of that nature would look like. But really, you should be still. And I'll show you the really cool part about how the camera can move in a second. That's why I'm trying to be really still when I hit the sample button, just for reference. So I'm going to go ahead and reset that. I'm going to hit sample again. And this time, once I turn the sample button on, I can see that these parameters at the bottom are now enabled. And I actually want to go ahead and turn on the normals, which is going to end up computing normals for the geometry that it creates after. And I'm going to turn on the texture button. Once you turn that on, the Z SDK is automatically, periodically through the scan, going to go ahead and take pictures of the environment through one of the cameras and then keep those sampled inside of that Z top that we created in the correct UV position, which we're going to see is really, really cool. Now, we'll come back to this filter in a moment. Let's go ahead and turn off our sample. Now you can see that one, as that sample procedure was held on and kind of active for a little bit of a longer time span, took a little bit longer time to return to us the results. So that's something that you're just going to have to experiment with and see how long it takes based on the complexity of what you're scanning and how long you keep that sample enabled. But what I can now see down here in my Z top is actually this really crazy arrangement of colors and textures. And what this is this is a full UV texture that I can apply back onto my geometry to color it. So if I was going to even do a really simple rendering setup here, what I could do is right-click on the output of my Z-SOP, switch my Op Create dialog over to Comps, select Geometry here, which is a nice shortcut to automatically get a geometry with my SOP plugged into it. And all I have to do is take this and apply it as a material. So in this example, I'll probably create a new constant matte. And for its color map parameter, I can just drag and drop my Z top onto that. Oh, and it looks like I missed there. And then the final step is applying my material to my geometry. So I can just go to the render page of my geocomp, and where I have material here, I'm going to drag and drop my constant matte. Now we can see here that it kind of worked, kind of didn't work. This is something that still you're going to have to experiment with a little bit. I find when objects in the environment move a little bit, it starts to get a little bit dicey. But let's go ahead and actually reset it and run the sample again now that I already have the normals and texture button turned on. So I'll go ahead and hit sample. I'll let it run for a minute while I pretend to be a ventriloquist. And then I'm going to turn off that sample button. And now you can see we have the same result, which is a mesh that has been scanned. We have that UV of myself and some of the environment behind me. And actually on our 3D model, we can see that it's been fully textured and all of the colors of that 3D scan are applied onto me. So that's really great. We can see that that works pretty well. So the last parameter that is a good one to know about is this filter one that we talked about earlier. And this filter one is going to tell the ZSDK how much filtering to apply across the actual sampled points. So by default, it's going to be set to low. And what this means is that it's not really going to try and mess with the geometry too much. It's really just going to try and plug a few holes, maybe just make sure things are connected and not broken as best as it can, but it's not going to go through and, filter chop eyes, if that's a word, filter chop eyes the rest of the data. But what we can do is say, you know what, if I'm maybe scanning something that's a little bit bigger, maybe a house or something, maybe the detail is not what I need, and maybe actually having a little bit of filtering is going to be useful. So we can see this example mesh that I have has low filtering. Let's just run the same thing, but this time after I turn on the sample button, I'm going to switch this filter to high, and we're going to take a look at the result here. So I'll turn on sample, switch my filtering to high, let it run for a few seconds here. We can see it filling up those points nicely. And then I'm going to go ahead and turn off that sample button. Now in this case, you can see that the geometry is much less dense. Actually, in some ways, depending on what your use case might be, this might even be better for artistic purposes than having more detail. That's something that I always tell folks, is that detail doesn't always equal quality. And in this case, we still have the same result, which is going to be a great color texture created here. We're going to have our mesh created, and both of those things line up just perfectly inside of our geometry over here. So there's a lot of creative potential that you can do by playing with these parameters, but I forgot to mention, I didn't forget, I was holding it back right till the end because this is going to be a great segue into what we're going to do in our next video next week. But one of the coolest parts about this process is the ZSDK is smart enough, especially considering that we haven't talked about the Z's internal sensors like the gyroscope and its positional sensors, but it's actually really great at knowing where it is inside of 3D space. So what that means is that we can actually start our sampling scan behavior here, and then start moving the camera and scanning all the things around us. And the ZSDK is going to be smart enough to do all of that kind of point fusion, mesh fusion, and make one unified mesh for us. So this is really cool. And this is how I created that scan of my very messy desk that you're about to see earlier. So what I'm going to do is I'm going to go back to my mesh here. I'm going to reset my ZSOP. I'm going to turn on sample just for a second, just so I can set my filter quality back to low, because there's a lot of kind of detailed small objects all around my desk. So we don't want it to get kind of too filtered in that mesh. So we're almost ready to scan my desk now. So what I've done is pointed my light down towards my environment here, just so it gets scanned nicely. I'm going to grab my camera here. I've got it on a GorillaPod, so it's nice and easy to hold onto. Give myself a little bit of cable leeway, and I'm going to go ahead, hit sample. And as it starts recording, I'm going to hit home here just so I can see it start to scan things. And I'm going to go ahead and move that camera nice and slowly through my environment here, and we can see it's adding more and more points as we go through. And don't be afraid to get a little bit of range, get a bird's eye view. And we can see it's continuing to go through, catch more and more points. And then I think we're just about done here, so I can go ahead and turn off that sample button. And we just have to wait for this to process. I found with a scan of about that long, you know, like a 30-second to a minute-long scan, you're looking to about 1 to 2 minutes to get that model coming back. It really is going to vary on what kind of resolution you have, how much filtering you have, the range you set. All of these things really play a part into what kind of mesh actually gets generated and comes out the other side. Especially in situations where maybe you don't need things like normals and textures, turning those off is going to help speed up the process. But we can see already, even with me not finishing my rambling, we have our 3D scan that's come back. And we can see here I've got a nice chunk of my desk, as well as all kinds of things on my desk. Lip balm, headphones, cups, iPads, lamps, and you name it. Now this is a good example of how you can see that the areas that are well lit have really well scanned kind of details, and the areas that aren't well lit or that are going to be hard for an optical sensor to kind of detect, like for example, we can see around my laptop, which is black, and I'm in a basement office, so it's a little bit darker in here. Those kind of details do get lost. So it's always good to do your best to light your environment. If you're scanning indoors, you may even kind of consider mounting a small LED ring light on top of the Z. That can give you a little bit of directional light as you're going through and scanning. But even with that said, we have a lot of really cool detail in here. We could switch to our wireframe mode, see that it's got a lot of good stuff. And you can even start to do creative things just with this example. So what I could do, a fun thing, is go to my constant map, go to the common page of my parameters here, and I can even set this from wireframe off to be GPU tessellated wireframe if you have a GPU. If you don't, you can use the topology wireframe, which is going to move that process back to the CPU. But in this case, I could do a GPU tessellated wireframe and even do something fun like do a 3D fly through of my colored, scanned, messy tabletop. So the sky is the limit in what you can kind of creatively do with this. The cool part that I really enjoy is that you can really get creative, move the sensor around, and it's going to handle all of the fusion for you and create one unified mesh, one beautiful UV, beautiful in the crazy looking kind of way, UV texture with all of the colors in it that you can just with 4 nodes apply inside of TouchDesigner and get up and running. So in the next video, what we're really going to do is actually take this outside where I think it kind of really shines when there's lots of light, and we're going to do a 3D scan of an environment. So we'll see you in the next one. Hey guys, thanks for watching. If you're serious about taking your TouchDesigner and interactive skills to the next level, I highly recommend you check out the Interactive and Immersive HQ Pro. It's the only educational resource and community of its kind for TouchDesigner and interactive professionals. You can learn more by checking out the link in the description. And if you like this video, don't forget to hit that like button. And if you're new here, don't forget to hit subscribe and the little bell icon for more awesome free content.